In this video, we're going to look at our first theorem we learn in geometry. To do that, we have to recap on a couple of things. A theorem is a statement obtained by logical argument from axioms or previous theorems. So this means a theorem is some statement or fact that we can say because we're able to prove it's true using axioms or previous theorems. We also need to remember that supplementary angles are pairs of angles that add up to 180 degrees. Now, if I click this link and I follow it, it'll bring me to a GeoGebra applet. Now, on this applet, we notice that we have a 146 degree angle at the top and a 146 degree angle at the bottom. And left and right, we have 34 degrees. And we'll notice that as I move this line segment, we notice that the vertically opposite angles, the angles that are opposite to each other, remain equal. So I can set them to 99, and then directly opposite, if there's a 99, an 81 and an 81 directly opposite each other as well. They're vertically opposite one another. So we can see here that regardless of where I move these two, regardless of what angle I put the line segments to one another, the vertically opposite angles remain equal to one another. Now, I've just demonstrated that using an applet. Another way we could do that is if you pause the video now and draw two random straight lines in your copy, and then you measure the angles on that, you should see that the vertically opposite angles are equal in measure to each other. Now, if we go back to the OneNote, we'll see that our first theorem is about trying to prove that those vertically opposite angles are equal in measure to one another. So we want to prove that this angle that I'm marking red is equal to this angle that I'm marking red. And we also want to be able to prove that this angle here is equal to this angle here. So they are vertically opposite angles. We want to prove they are true. To do that, we need to set out our theorem. The first thing I want to do is I need to state what I want to prove. So I'm trying to prove that vertically opposite angles are equal in measure. So we always start our statement by saying to prove vertically opposite angles are equal in measure. Then we have to look at what we are given. So in this proof, we are given two intersecting lines. Now, two intersecting lines are two lines that meet or touch each other. So this is where these two intersect, or at the point that I'm marking blue here, that's where they intersect. So we're given two intersecting lines. Well, we say lines or line segments, it won't make a difference, but we'll say two intersecting lines. So just to change these to lines, I'm going to add a little arrow at the end of each of them. So these are intersecting lines. Now, this is called the split page method here. So I'm going to make a statement on the left-hand side of the page and then state the reason that it's true. So the first statement that I'm going to say is that, well, first off, I have to actually give myself a little bit more space and include a diagram actually, which I forgot to do. So here's my diagram. So this is the diagram I'm going to use for this. Now, just make sure it's perfect. What I want to do is I want to make sure I have actual straight lines. So I'm going to do one straight line there, and then I'm going to copy that, or else I'm not, because it's not going to let me. It's pure awkward. Okay, well there I have two two intersecting lines. And again, just to make sure they're lines, I'm going to stick the arrows on the end of each line segment to turn it into a line. So the angles I have, I'm going to label this as angle 1 for simplicity. I'm going to label this one as angle 2, and I'm going to label this one as angle 3. So I have 3, 2, and 1, okay? So the first statement I'm going to make is that the angle 1, so if I write it down like this, the measure of the angle 1, so the lines outside mean the measure of, The symbol in next symbol means angle, and then the 1 means we're talking about angle 1. So angle 1 plus angle 2 is equal to 180 degrees. And the reason I can say that is that if we look at this entire angle here, that's a straight line. So we have a straight angle. So the reason that's true is it's a straight angle. So a straight angle is equal to 180 degrees. The next statement I'm going to make is that the angle 2 plus the angle 3 is also equal to 180 degrees. And again, the reason that's true is that's another straight angle. So the straight angle is equal to 180 degrees. So 2 plus 3 is also equal to 180 degrees in this case. Next, we're able to say, well, we know that angle 1 plus angle 2 is going to be equal to angle 2 plus angle 3. Because both of them are equal to 180. So if both are equal to 180, they have to be equal to each other. So now, using algebra, I can subtract angle 2 from both sides of this equation. And that means I'll be left with angle 1 is equal to angle 3. So the reason I was able to say that again was a small bit of algebra. So now I have angle 1 is equal to angle 3. So that's implied. So that's shown to be true. Okay, and again, that's implied as well. So I'm showing the implied symbol there. So we've shown that this angle here, the angle 1, is equal to this angle here, the angle 3. Now you might notice that in this proof, we never said the angle was a specific size. We never said angle 1 had to be 40 degrees, for example, or angle 2 had to be 60 degrees, for example. We never said anything like that. We talked abstractly. Because we talked abstractly, we've proven this is true for any vertically opposite angles. It doesn't matter what size. That is our first theorem, and we have now proven that vertically opposite angles are equal in measure.